Hello everyone, welcome to Shibi's chemistry classes. Today we have to do some practice questions based on chapter number 1. Chapter number 1 is periodic table and we have to do some questions related to this chapter. So I have written some questions, we will do one by one. First question is arrange the following. A. Decreasing order of ionization energy. So ionization energy, we all know that it is the amount of energy required to remove electron from the valence shell. And these elements, we know that they belong to group number 1. If you remember group number 1 elements, they are hydrogen, lithium, sodium, potassium. 1, 3, 11, 19. 1 electron. Potassium is having 4 shell and last shell has 1 electron. So if you look at the structure of these, hydrogen is having only 1 shell and potassium is having 4 shell. And as we are moving down the group, the atomic size is increasing. And we know that as the size of atom increases, the removal of electron will become easier. Why? Because the force of attraction between positive charged nucleus and electron will become less. And if the force of attraction is less, the nuclear pull is less, then electron removal will become easy. So as we move down the group, the value of ionization energy is decreasing. So here what will be the order? The highest value will be for hydrogen, lithium, sodium, potassium. So this is the decreasing order of ionization energy. Hydrogen will have the maximum ionization energy and potassium will have the minimum ionization energy in this case. Second is increasing order of electron affinity. Electron affinity is the amount of energy released when an electron is added. So the more is the size of atom, the less is the tendency to accept electron. Because why? Because the nucleus will not pull the electron with that much force that is required to accept the electron. So bigger the size, less is the amount of electron affinity and less is the acceptance of electron by the atom. And smaller the size, more is the electron affinity value. Means smaller size is favoring the acceptance of electron, and we know that as we move along a period, the value of electron affinity increases. Value of electron affinity increases as we move along a period due to decrease in atomic size. And these elements belong to second period. Second period elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. 1, 2, 3, 4, 5, 6, 7, 8. These are second period element. 3, 4, 5, 6, 7, 8, 9 and 10. 2, 1, 2, 2, 2, 3 and so on. So you can see that from the electronic configuration, you can see that they are having 2 shell. So that means they belong to second period. So here what is happening as we are moving along the period, the size of the atom is decreasing, so the value of electron affinity will increase. So here what we have to do, increasing order of electron affinity. So which element is coming first? Boron, the minimum amount of electron affinity value. Then comes here the boron, then oxygen, nitrogen, fluorine. These 4 elements are given. So first boron will come, then nitrogen, then oxygen, then fluorine. So boron will have the minimum value of electron affinity and fluorine will have the maximum value of electron affinity. Next is increasing order of number of shells: helium, neon, argon. So these elements belong to group 18. Helium, neon, argon, krypton, xenon, radon. Group 18. Starts with helium 2, neon 10, argon 18. Configuration: is 2, 2, 2, 8, 2, 8, 8. See, you can see that its duplet is complete, so it is stable. octet is complete, so these are also stable. So what we have to do, increasing order of number of shells. So let's draw the structure. 2 shells in case of helium, 2 electron here, 2 electron here. Sorry, only 2, na? 2 electron, only 1 shell it is having. Sorry. Helium configuration is also 2 electron. Then neon, 2 electron, 8 electron. Argon, 3 shells, 2, 8, 8. So as we are moving down the group, the number of shell is increasing. So you can see that the number of shell is maximum for argon and minimum for helium. So increasing order will be helium, neon, argon. So reason is as we move down the group, the number of shell increases. Next is increasing ionization energy. Increasing ionization energy. Here what we did, decreasing order of ionization energy, here increasing. So the one which is having the minimum in this case is the one with the bigger size. Who is having the biggest size here? Lithium, sodium, potassium. Lithium, sodium, potassium. The potassium is having the biggest size, so it will have the minimum value of ionization energy. Potassium, sodium, lithium. So lithium will have the maximum ionization energy value, then sodium, then potassium. Next is increasing electron affinity. So who is having the maximum tendency to accept the electron in this case? Fluorine, chlorine, bromine. 17 group element. They are 17 group element. Fluorine, chlorine, bromine. So we know that as we move down the group, the value of electron affinity decreases due to increase in the size of the atom. Because if the size of the atom is more, it will not favor the acceptance of electron. So it will be difficult to accept electron due to less attraction between the nucleus, positive nuclear charge and the outermost electron. So they will not accept. The tendency decreases as we move down the group. But here what we have to do according to increasing electron affinity. So which one will have the most maximum value for electron affinity? Obviously, the less will be for bromine, then fluorine, and fluorine will have the maximum value for electron affinity. Then increasing atomic size. Increasing atomic size, lithium, sodium, potassium. First group element, as we move down the group, with the addition of new shells, the size increases. So the bigger size will be for potassium. And lithium will have the smallest size, then sodium, then potassium. So this is how you have to solve this type of questions along with the reason. If it is asked to write the reason, then you have to write the reason also. Next question is, an element has electronic configuration 2881 287. So based on this, you have to tell first name of element, second atomic number, then group, period, You can add more to it. You can tell valence electron also. Valency. This is how the questions will be asked from this chapter. So an element has electronic configuration this and this. Based on this information, you have to answer this question. So first we'll see what is the electronic configuration. From the electronic configuration, you can find out the atomic number. 8 plus 2, 10, plus 8, 18, plus 1, 19. 19 is the atomic number for potassium. And from the last configuration of the last electron, you can see that it is 1. So definitely it will belong to group 1. It will belong to group 1. Atomic number we have already seen, it is 19. Element is potassium. Group number is 1. Period is the number of shells, 4 in this case. So period is 4. Valence electron is 1 and valency is also 1. So this is how you have to solve this type of question. Second is 287. 8 plus 2, 10 plus 7, 17. Chlorine has 17. Atomic number of 17. Okay? So here 7 electron in the valence shell. So valence electron is, so the element is chlorine. Atomic number is 17. Group, to which group it will belong? Last shell it is 7, that it belongs to 17th group. Period 3 shells, so third period. Valence electron is 7 and valency is not 7. Valency is 8 minus 7, that is 1. So they can ask any element giving the electronic configuration. You have to find out the answer like this, based on this. So for that you should at least know the elements up to 20 atomic number in the periodic table. First group, second group and so on. You should know that what are the group 1 elements and which elements belong to. Period wise you should know the elements also. So this is how you have to solve. Give reason. Next question is, give reason. Ionization energy increases across a period. So you have to give reason for this question. The question is ionization energy increases across a period. So we know that ionization energy is the amount of energy required to remove electron from the valence shell. So as we move across a period, the size of atom decreases. Let's take example of fluorine. Fluorine atomic number is 9, configuration is 2, 7. 7 electron in the valence shell. So as we move across the period, what is happening? As the atomic size is decreasing, the distance between the valence electron and nucleus is decreasing. As a result of which, the force of attraction increases between these two and it will not favor the removal of electron. So removal of electron will become difficult as the atomic size decreases. And because of that, the value of ionization energy increases. So to remove the electron, we have to apply more and more amount of energy. So the reason is due to decrease in atomic size. Next question. Question is match the atomic number. So some atomic numbers are written: 2, 4, 8, 15 and 19. 2, 4, 8, 15 and 19. These are the atomic number, and you have to match this atomic number with the statement that is given below. What statement is given? A solid non-metal belonging to third period. A solid non-metal belonging to third period. So you have to find out which element that is non-metal and it belongs to third period. Atomic numbers are given here. So with this atomic number, you have to find out the elements first. 2 is the atomic number for helium. 2 is for helium, 4 is for beryllium, 8, who is having 8? Oxygen, this is phosphorus, and this is potassium. You have to learn this atomic number along with the symbol. What atomic number belongs to what symbol or what element. So you have to tell a solid non-metal belonging to third period. Now how we will find out the period number? By doing the electronic configuration. Electronic configuration is 2 for helium, 2 for beryllium, 2 6 for oxygen, 2 8 5 for phosphorus, and 2 8 8 1 for potassium. Now what you have to tell? A solid non-metal belonging to third period. So who will belong to third period? The one which is having 3 shells. So it is obviously phosphorus. The answer will be phosphorus. Second question is, a metal of valency 1 who is having valency 1? You can see here it is potassium. A gaseous element with valency 2. A gaseous element with valency 2. Now this is a bit tricky. Here you can see 2, here you can see 2. So most of the children, they must be thinking that the answer will be beryllium or the answer will be helium. Isn't it? कुछ लोग सोच रहे हैं कि आंसर will be helium. If it is helium, then why? If it is not helium, then why? Because helium is showing 2. According to the configuration, you can see that it is having valency of 2. Most of you are thinking like that. By seeing the electronic configuration of 2 over here, you must be thinking that helium is the answer for this question. But no, that is wrong. Why? If you recall what I explained you, helium is group 18 element. Helium belongs to group 18. Helium, neon, argon, and group 18 elements, they are extremely stable. They neither donate electron nor they accept electron. If they are not participating in chemical combination, that means their valency is 0. 8 minus, so valency is 0 actually, for group 18 elements. So this will not be the answer. Then what is the answer for this question? Let's see oxygen. Valence electron for oxygen is 6. So valency is 8 minus 6, that is 2. And oxygen, we all know it is a gas. So answer is oxygen. An element belonging to group 2. Group 2. Group 2. If the valency is 2, that means it belongs to group 2. So element is beryllium. A rare gas. A rare gas is helium. I hope you all are understanding what I'm explaining here. So if possible, I will make another video and take some more questions. So till then, bye-bye.